Question number 33. In the GM experiment, alpha particles are accelerated to a PD of 7.7 megavolt. And instead of zinc gold foil, the proton number is 79. And what is the distance of the closest approach? Now, what do we do? What do you mean by distance of closest approach? When do we use this? We say, see, alpha particles, these are alpha particles, which comes over here, and you keep the gold foil over here. So this comes over here to a minimum distance, and after that, it either gets deviated like this, or maybe it gets rejected like this, okay, depending upon whether there is a head-on collision with the nucleus or not. This is what the minimum distance. The minimum distance between the alpha particle that it can approach the gold nucleus, okay, is called as a distance of closest approach. Okay, so therefore, now what happens? This will have some kinetic energy. Without a kinetic energy, this object will not move. This alpha particle will not move, right? So let us say, what is the kinetic energy here? We say it has been accelerated with a potential difference. See, the potential difference means having some energy, which is given by E times 7.7 megavolt. This is the energy of the alpha particle. Now, as it comes here, what happens? 7.7 becomes 5 to 1, 0.01, and so on. When it comes here, it becomes 0, right? And it's about to collide, but it cannot collide. Okay? It cannot come in contact with it because the repulsiveness of this one is much higher, because it's 79 and this is nothing but the 2 over here. It repels a lot. Okay, now when it comes over here, so here what was the kinetic energy? The kinetic energy was seen to be 7.7 MeV. What was the potential energy? Potential energy was 0. Why is 0? It is not under gravity, first of all. Okay, gravity is very less, and the distance of this particle with respect to this one is too large. So therefore, I will say potential energy is equal to 0. Now when it comes here, it literally comes to a stop. What is the kinetic energy? 0. And what is the potential energy here? Potential energy is nothing but K into Q1. What is Q1? Q1 is here it is 2E, right? 2E, charge on the alpha particle, multiplied by what is charge on the gold nucleus? 79E. 79E divided by distance. This is what is D here. D. How did I get this expression? You would have learnt in your electrostatics the potential energy. Electrostatic potential energy is given by K Q1 Q2 divided by R. This is something which you have learned. I employ the same thing. It is nothing but electrostatics and conservation of energy. Okay. So what is conservation of energy? This energy sum is equal to this energy sum. That's what I'm going to do. Okay. This is your direct derivation of your distance of closest approach in your GM experiment. But I'm doing the same thing. So therefore, I will write this as 7.7 plus 0 is equal to K into 2E into 79E. 79E. Sorry, this is 2E, not E. 7.7. I'll write this as kinetic energy is equal to 7.7 m into 2eV. I'll write like this. 7.7 m into 2e divided by dO. Now I want to get the value of d plus 0. So what will happen? See, here they have 2e, this 2e goes away. Now what is left behind here? I have this one. So I get the value of d as d is equal to k to 79e divided by 7.7 into mega is 10 power 6. That's it. Let us see which answer corresponds to it. K into 79e, 79ke divided by 7.7 into 10 power 6. Answer C.